In the previous video, we've seen what the batch processing recognition sample does in practice, where the project is located, how to run it, how to configure the demo, and how the results compare between sequential and multicore processing. In this video, we'll shift from the user interface to the implementation and walk through the code behind the sample step by step. When the form opens, the application first creates the user interface and then starts initialization in the background. It loads FineReader Engine, verifies that a license is available, and locates the sample data folder. If a previous settings file exists, those settings are restored, including the source folder, output folder, CPU core selection, and the last saved performance chart. Otherwise, the sample falls back to default settings and a default image folder. It then loads the available recognition languages, updates the folder control descriptions, enables the form, and closes the loading screen. The temporary engine instance used during initialization is then unloaded. When the user clicks Start, the application first validates the selected settings. It checks that the source images folder is specified and exists, that an output folder is provided, if PDF export is enabled, and that at least one recognition language is selected. If any required input is missing, the application shows a corresponding message and stops. If the settings are valid, the application creates the output folder when needed, opens the progress dialog, disables the main form, copies the selected values from the interface into the settings object, and starts the processing on a separate STA thread so the user interface remains responsive. In the processing thread, the sample loads FineReader Engine again and begins the test workflow. It first loads the predefined profile, creates PDF export parameters, and sets the PDF export scenario to maximum speed. Next, it prepares the page processing parameters. After that, the application loads the list of input image files, creates a FineReader document from those images, updates the total page count in the progress dialog, and switches the progress display to the recognition stage. The sample first runs the baseline test in sequential mode. It switches the engine multiprocessing mode to sequential and processes the pages already loaded into the FineReader document one by one. For each page, it updates the progress dialog, then calls preprocess analyze recognize, which performs preprocessing, analysis, and recognition in a single step. If PDF export is enabled, the page is then synthesized and exported as a searchable PDF before the next page is processed. When all pages are completed, the application measures the elapsed time and calculates the throughput in pages per minute for the single core run. After the sequential test finishes, the sample forces garbage collection and waits for finalizers before starting the multicore run. This cleanup step helps reduce interference between the two measurements. The second test is the multicore run, which uses the batch processor. At this point, the engine is already loaded, so the sample switches the multiprocessing mode to parallel, sets the number of recognition processes from the CPU core selector, and loads the engine processor module required for multiprocessing. It then creates the batch processor object and prepares the batch input source. In this sample, the input is provided through an image source callback built from the list of image files, so the engine can read and process the images asynchronously. Once the batch processor and image source are ready, the application calls start. This initializes batch processing, launches the parallel recognition workflow, and passes in the image source together with the page processing parameters. After the batch has started, the application enters a loop and repeatedly calls getNextProcessedPage. Each time a processed page becomes available, it is returned to the application. The loop continues until the method returns null, which means that there are no more processed pages left to retrieve. Each processed page must be handled immediately after it is returned. In this sample, if PDF export is enabled, the page is synthesized and then exported to a searchable PDF before the next call to getNextProcessedPage. This is important because the page object returned by the batch processor is only valid until the next page is requested. As in the sequential test, the sample measures the total processing time for the batch run and calculates throughput in pages per minute. For this result, it stores the number of parallel recognition processes used during the test. Finally, when processing is complete, FineReader Engine is unloaded. Both sequential and multicore runs use the same input documents and the same recognition settings. The difference is not in the recognition profile or output quality, but in the processing model, sequential in one case and batch multiprocessing in the other. When processing is complete, the application calculates the throughput for each mode and displays the comparison in a chart. The results are saved, the interface is restored, and the application is ready for another run. This demo shows how FineReader Engine scales from simple single-core processing to efficient multi-core batch processing while maintaining the same recognition quality.